Good morning. I'm Dr. Olga Segbu. I'm here with the NEMO project on behalf of Net Company Intrasoft. Many thanks to the Eclipse Foundation for the kind invitation to this workshop that allows us to also share our views on how to better integrate the meta operating system with the concept of a data space. So, what is the motivation for this work? So, initially for us, NEMO was not designed as a project that was focusing a lot on integration of data spaces, but it became quite important because data spaces are supposed to be the vehicle for data-driven innovation in the EU. We already know that there are many commercial solutions like data warehouses out there, but there are a lot of aspects that make data spaces unique, especially the tighter form of governance that they offer and the built-in compliance to EU legislation. So it became quite important to us to see how we could extend our architectural approach to embrace data spaces, knowing that the concept of the data space actually mandates the efficient use of resources across the AIoT and the cloud edge continuum with clear mechanisms that can enforce security and privacy. So herein we are going to be seeing a bit of a case study on how we managed to integrate the fiber-based industrial data space connector within the NEMO MetaOS architecture in order to access and valorize large pools of data. So what were the main challenges that we foresaw in this aspect? So we know that the cloud edge continuum and the AIoT continuum is a very dynamic environment. We know that we can see services being created and torn down within seconds, and within seconds, massive amounts of data can be generated. So we also know that there is a big heterogeneity of systems that can be integrated within this ecosystem and a lot of different administrative domains. So we are also taking a look at the distribution of computational power across this continuum that includes more and more hardware heterogeneity and virtualization heterogeneity. And we are designing the meta operating system in order to handle these aspects and handle the growing density of devices and the opportunistic scheduling that needs to be supported as the norm. So the concept of the meta operating system, it is designed to take all these factors into account and provide better resource orchestration, better management, better optimization mechanisms. And we also know that the data space concept is created for the ethical exploitation and improved governance of data. So these two concepts becomes quite clear to us that they are quite complementary. The MetaOS can be used to improve the management of data sources, whereas the data space can be used to improve access to the data themselves, improve data availability and data quality. So it was quite important to us to see how we could connect these two architectural paradigms together. So, but why do we need data spaces specifically for this? So, since recently, we do know that there are commercial solutions like data warehouses, but these are not covering all our needs because they are more or less designed to be centralized databases and designed around structured data unification. So the vision for the European data space is quite different. It is supposed to offer a more decentralized solution to facilitate the availability of data. And this data can be either structured, semi-structured, or unstructured. So as long as we have secure peer-to-peer communication, as long as we can have tight control of access and use privileges, then we can have a secure European data space that is more trustworthy, that is standardized, as also Boris suggested a few minutes before during his speech. And more importantly, this is a vision that already integrates EU legal compliance that is built in by default and by design. So we take into account all the newer legislation like the AI Act, the Data Governance Act, and the General Data Protection Directive. So in this work, we find it is very helpful to base our design on the International Data Space Association reference architecture. That was the big first step to reviewing how we could integrate to the data space. So access to the data space can be performed via the data space connectors, and gladly there are many open source solutions that already exist, such as the Eclipse Data Space connectors that is powered by Gaia X, and the Fire Data Space connector that we will be seeing today that follows the NGSI protocol that is developed by Fireware and is already standardized by ETSI. So in our case, there are two meaningful ways that the data space can be integrated within the Meta operating system. Either by integrating an existing data space via a plugin manager that we are going to be seeing next, or by creating, perhaps in the future, a separate data space that can be shared among the different instances of the Meta operating systems. So what is our approach here? So we have already seen that this space, this ecosystem is highly dynamic, and services can be created and torn down in seconds, but also the development cycles themselves have started to become quite faster. So the concept of NEMO is to complement zero-code tools and ontology-driven NLP to bring fast developer cycles, fast deployment cycles, fast management by complementing it with zero-touch orchestration and management. So that is handled through an intent-based zero-code microservice programming concept. And this approach is designed with opportunistic migration to be the norm rather than the exception. So our ambition is to facilitate easy zero admin knowledge and almost instantaneous deployment to nearly any AIoT device to address the current ecosystem need to integrate and bundle all these mechanisms into one software package, and also handle the easy addition of features via a plugins mechanism. So let's see exactly how we structure this system. So basically, we know that there are underlying elements that can be quite diverse, like hardware resources, virtualization, etc. And we have designed a kernel layer to be the core interface between all those different virtual and physical infrastructures. So the kernel layer handles what lies under the hood, let's say. What is quite important for us today within this concept of integrating to data spaces is the upper layer, the service management layer that handles the workload lifecycle management and provides additional services in like privacy, security, identity management, etc. So in order to integrate an industrial data space, we will be looking at the way that NEMO handles the onboarding of plugins, as you can see right here, and how this process is managed by the intent-based SDK that NEMO has already designed. So by using the reference architecture of the IDSA as a starting point, we know that the MetaOS can be used as is to host and provision all the required services like the clearinghouse, the app store provider, etc., via the intent-based API that you can see right here. So NEMO has already created structured workload documents that can give us a lot more information than a standard deployment descriptor. So it can also include information about monetization or security, various types of dependencies. So the workload documents can give us a lot of information about the specific workload. Then the intent-based API is basically the component that allows us to first validate a workload, register a workload within NEMO, and then provision this workload. So in order to provision a data space connector, first we need to onboard it via this API. So what happens is that the workload first needs to be validated and checked against some requirements provided by NEMO, whether there are document requirements, for example, security checks, dependency checks, etc. So if this specific plugin passes these specific checks, it can be then registered in a specific NEMO registry that holds static information about all the different workloads. And then a token can be created, then this token can be used by any sort of consumer to provision this plugin. So when a workload needs to be used and provisioned for a specific consumer, then it will first check a variety of annotations that are added by NEMO. For example, what are the compatible VIMs for this workload? Am I attempting to deploy in a virtual infrastructure that is compatible with this workload? As long as these validation checks work out, then the deployment can be initiated, and the intent-based API will communicate requests to the rest of the NEMO components, like the plugin's lifecycle manager, the meta orchestrator, access control, etc. So let's look into how we try to apply this, the Fireware case study. Here we are suggesting the use of the Orion context broker that is already standardized, and we provide a sort of our tentative architecture on how this connector can be bundled with NEMO. So what is important here is to ensure that the access to the content broker happens through an access control mechanism. That is very important because it makes sure that access control criteria need to be respected by both sides, the side of the Meta OS, the side of the consumer, and the side of the data space. So the important thing here to note in this case study is that the access control that is enforced here by NEMO goes way more it goes beyond what is typically associated with access control. It doesn't just stick to authentication and authorization of the data access, but it can provide additional services like blacklisting, rate limiting, etc. So basically, this component right here is the important part of the access control, and the access control here provides the access to the Orion context broker, which is the main part of the integration with the Fireware data space. So in conclusion, NEMO at its conception was designed to bring powerful orchestration to the AIoT and edge cloud continuum. And although integration with data spaces was not foreseen in the beginning of the project, it became quite important to us to find out how to better integrate it with data sources. So although we did not initially consider data spaces, we found that the way that we structure our architecture was flexible enough and gave us tools to integrate through the plugins manager and the intent-based API. So as future work, we aim to validate this proposed connector and verify how data commercialization can also be validated through the Meta OS infrastructure that we have already created within the NEMO project. So, any questions? Sure. Well,